Hello, this is the genuinely approachable Sudoku for the 21st of January 2024. It is Point Next by Clover. So, another rule using these large arrows. So, what are the rules? Normal circle rules apply, so it's 1 to 9 in every row, every column, and every 3x3 box. If a digit in a cell appears in a cell with an arrow, so if a digit appears in a cell with an arrow, the digit 1 greater than it must appear somewhere in the direction that arrow points. So for example, if this arrow was a 2, for example, if this arrow was a 2, then the digit 1 greater than it, that is a 3, must appear in this direction. So you put a 3 here, or something like that. So those are rules. For instance, there must be a 6 somewhere in the bottom 3 cells of column 4. So one of these must be a 6, yeah, because 5 points in this direction. Alright, so with that, let's begin solving. Now, these arrows probably tell us stuff already. Not sure. But it does tell us that 9 is in one of those cells. 7 is in one of those cells. 4 is in one of those cells. In fact, one of those cells because 4 is already there in the column. And 6 is in one of those cells. Okay, not very helpful. But you could probably use these arrows as well. Because the arrows actually work in two ways. Not only does 8 point to something that is 1 greater than it, you can also say that if you have all these values, you can put some numbers in here. So whatever these values are, this could either be 1 less than this or 1 less than this. It cannot be any number else, because if it was any number, say 5, then it wouldn't follow the rules, because it wouldn't be a 6 in any of these cells. So this is either a 7 or a 3, and this is either a 1 or a 5, but it can't be a 1, so it has to be a 5. And this one is either 3 or 5, but it can't be 5, so it's a 3, which means that's a 7. This is either 1 or 7, I think, but it can't be a 7, so it's a 1. So last digit that would be a 9. Oh, in fact, 9 cannot be on an arrow, because 9 cannot point on something that is greater than it. So that's something we can talk about as well. Because there's nothing greater than 9, so you can't have 9 on an arrow. And in fact, let's talk about... Well, let's not talk about that, because I think it's a lot easier to just look at this. This is either 6 or 8. This is either 2 or 4. This is either 4 or 8. And then this is either 2 or 6, but 2 here sees that. So that's 6. That makes this an 8. That makes this a 4. That makes this a 2. And the last digit is 1. I should also just place 1 here, because those digits are always going to be 1 less than whatever this is. So those digits are always going to be even, because these digits are all odd, which means this will be the last odd digit, which would have to be 1. So that's another trick you can use. 4 sees that cell, which means that 4 must be here. Okay, so this cell over here sees one of those cells, so it's either a 3 or a 5, but it can't be a 3, so it is a 5. This one sees those cells, so it's either a 2 or a 4, but it can't be a 2, so it is a 4. Okay, this can't be a 7, and in fact this 7 sees one of those cells, so 7 is one of those cells, which then sees that cell, so 7 goes here. Okay, could probably do some Sudoku here. Yep, these 9 see all those cells, so 9 goes here, meaning this is not 9, meaning 9 goes there. And we can talk about this arrow, which has to be either 8 or 1, which we don't have anything to resolve, so that's fine. This 8 is resolved. Actually, this 6, 8, 5, and 3, they're all resolved at this point. This 5 is not yet resolved, but we already know all these are 6s, and in fact we know one of these cells are 6s, right? So those cells there, along with that 6, remove 6 from both of those cells, which means 6 goes here. Okay. What now? 3 is in one of those cells. I think it's just normal Sudoku, except for like these cells here. Oh, in fact, right? Yes, in fact, I can tell you something about where 7 goes in this cell. Because can this cell ever point here? It can't, because like we said, 9 cannot be on an arrow because it can't point to anything greater than it. But 1 cannot be pointed to by an arrow because this the arrow cannot be smaller than 1. So this arrow always points to this cell. And that means that if this is 7, it must point to 8. But if this was 7 here, then it must be pointed to by 6, which is not possible. So this must be 7 pointing to 8. Okay, more digits. Very cool. So 8 is one of those cells. I can put those digits down. Those are 1, 5, 7. Sorry, not... Wait. No, sorry, they're 1, 7, and 9. Sorry, I can't read. This is not 1, 7, so that's 9. Which means that is a 1, 7 pair. This digit can be pointing here, and therefore must be pointing here. And there are actually 2 and 3 to complete the box, so 2 must be pointing to 3. Okay, so those digits are 2, 5, 6, I think. Where this can't be 5 and that can't be 6. Those digits are 3, 8, 9. Where this digit can't be 3. Oh, whoa, this can't be 3 and that can't be 8 or 9, so that's actually just 3. Okay. Those digits are 2 and 8. That 8 means that's a 2. That's an 8. Those digits are 7 and 9. This 7 here makes that a 9, so that's 7. Those digits are 1, 5, I think 1, 5, 6. And 5, 6 here makes that a 1. 6 here makes this a 5. That's a 6. And so those are 3, 4, 9. Yeah, 3, 9 here makes that a 4. This is 3, 9 pair. Okay, now let's look at those digits. Those digits are 1, 2, 8. This can't be 2, so that makes 1 or 8. These are still 1, 2, and 8. Well, this forms a 1, 8 pair here, which means those digits would be 4 and 5. Yeah, 5 here makes that a 4, that's a 5. Six is not on that cell, but there's 6 over here. So those digits are 1, 7, 8. Can't do anything there. Okay. I think those digits are 3, 9, and 7. 7, 9 can't go here, so that's 3. That's 9. That's 7. That's 3. This digit is also 1, 2, or 8. This 8 sees that cell, so that's not 8. 7 here sees that, so that's 1. That's 7. 6 sees that. Wait, did I remove the wrong digit? I did remove the wrong digit, sorry. So it will look like that instead. Okay. Almost made a mistake again. 3 sees that cell, so that's 3. 3. 1 and 7 see that cell, so that's not 1 or 7, that's 8. Those are not 8. Okay. Could probably do a bit more here. Yep, that 8 makes this a 9, that's an 8. That can't be 8 now. So those digits are 1, 2, 4, 9. Yeah, okay, I don't see anything I can do with it. Let's just do normal Sudoku again. 2 is in one of those cells. No idea what that does. 9 here sees all those cells, so 9 goes there. So this is 1, 2, and 4. Sure. 6. No. 7. 7 we also don't know actually. This is 1, 2, 7, and 6. Wow. Okay. Then what does this see? If this is a 7, this would be a 6. But there's also a possibility that's 8, right? Because what are we looking at? 1, 6, 7, 8. This can be 1 or 8. That can be 7. But the point is that, you know, if this is 7, it would see a 6. If this is a 1, it would be seeing this cell instead. And actually, this can never be 8, right? Yeah, because 8 cannot point to 9, so that can't be 8, meaning 8 must be there, which points to 9. So that's 1, that's 2, that's 8. So 6 could point to 7, and 1 can't point to anything, because 1 can't point to 2. So it can't be 1, meaning it's 6 pointing to 7. That's 7, that's 1, that's 7. Okay. So resolved everything basically. 1 here sees that cell. Could have done that as well. This can be 2. Chocolate teapot, very nice. Actually, yeah, this is 5 or 6. Those digits are 1 and 2, I think, which is resolvable. 2, 1, 2 places a 5 there. 5, 6, 2, 5. This is 6 and 4, which we can resolve. That's 6, that's 4. Solving the puzzle. Alright, well, that was cool. I hope you enjoyed that video. I'll be seeing you now. Bye bye.